Recall from first semester that the derivative of something like x squared minus 6x plus pi would be something like 2x minus 6, because you go 2 times 1 to get 2, and then you subtract 1 from the 2 to get 1. So you go derivative of this piece and then subtraction, and then the derivative of 6x would be just 6, and then the derivative of pi would be 0, which is why that is our derivative. What about the derivative from first semester of something like, let's say, 1 half x to the power of 5 minus e to the power of x? What would be that derivative? Well, let's go 5 times 1 half there. And then we take away 1 from 5 there. And then subtraction. And then the derivative of e to the x is itself. All right, so that was from first semester. Let's stay with first semester. What about the derivative of natural log of x? Recall that the derivative for natural log, you'd go 1 over that thingy, whatever it is, and then you multiply by the derivative of that thingy, and the derivative of x would just be 1, right? So now, well, one more, and then we'll discuss how we're going to turn this around. So what about like x to the 4 plus 2/3 x cubed minus 6x squared plus x, just like that. That derivative would be 4x cubed plus, let's see, 3 times 2/3 would just be 2. And then like this here. So this would be the derivative. So we know how to go from here to there. That's the derivative. But when you go from here back to there, that is when you find what we call an antiderivative. And that's what we have to do now. How do I go from here back to the original thing that it came from? So let's do a couple of examples here. For instance, x squared. What about like, let's say 2x? Can you take me to the antiderivative? What would be the antiderivative of 2x? Well, it would be x squared. Because what is the derivative of this? Boom, it takes you back there. What about this? What about x to the power of 4? Can you tell me the antiderivative? Not the derivative, but backwards. I want something here where the derivative of this gives me that. So if this is x4, then you know that the anti would be something x5. But dude, what goes here? So here's what you do. Here's a trick. The new exponent, 5, flip it. That's 1/5. And you put that in the front. That's how this works. So watch. Let's take this derivative. 5 times 1/5 cancels out. And then it just be x power 4 because you subtract 1. And boom, that's what this says. There's a 1 x4. That's how you can find an antiderivative. What about another one? What about like, let's say x to the power of 3? What would be the anti? Well, you know it's something x4. Now you take the 4 and you flip it, and boom, 1/4. This would be an antiderivative of that. One more, and then we'll begin the stuff. What if you have like a 3x7? What would be the antiderivative? Well, ignore the 3 for now. Just pretend it's not there. Just ignore it for now. Look at x7. The anti would be x8 with a 1/8, right? But now let's be honest. There was a 3 originally, and that 3 just transfers through. And you go 3 times 1/8, which is 3/8, and you keep the rest the same. So this could be considered an antiderivative of that there. Now we're ready to begin. So what we want to do is this. We want to find the area. Let's say something like this. You can jot this down if you want, just making this up. Let's call this y equals x squared. And we want to go from, let's say, from 1 to 2. We want to find that area of that little bit here. We want to find this area. Okay. So here is what we do. You're going to need this equation. You're going to have to go draw this symbol and then put a, b, and then put f of x dx, and then go like this. Capital F of b minus capital f of a. So here is what we do. We're given an equation, and that given equation goes in for f of x. As a matter of fact, just pretend this says f of x, okay? So the given equation is going to go in here. Now, who are a and b? Well, a and b are the numbers 1 and 2. And in dx, just leave it dx. And I'll show you what these mean over here, okay? So just jot down this formula on your paper, and then let's actually put this to use. So let me write this down a little bit smaller. So we're going to use a to b, f of x dx. Let me write this. Let me be really careful with how I write this. I want to be neat like that. Okay, equals big F B minus big F A. So when you fill these things in, you're going to get the integral. That's what this is called. That symbol is called, it's what we call an integral symbol, okay? Integral. That's the name of that symbol. It's an integral. So for this problem that I just made up, we're going from 1 to 2, the two given numbers. That's a and b. Now, in the parentheses, you throw in the original equation, which would be x squared. And the dx is just punctuation. It just goes along for the ride. So equals, and for now, let me just put a green question mark. Leave that alone for now. So here's what I want you to do. Over here, I want you to find big F. And big F, let me tell you what that is. Find big F. And big F is the antiderivative of little f, where little f is the original. See that? So the original equation is little f. I need you to find big F, the antiderivative, like we were doing in the warm-up just a moment ago. So let me put a period. So let's find big F of x. And that would equal the antiderivative of this. So what is the antiderivative of x squared? The antiderivative of x squared is 1/3 x cubed. That's big F. And now to get the answer, all you have to do is find big F of B and then minus big F of A. And that'll give you the answer. So let's try this out. So let's find now that we know big F, let's find big F of B, which is F of 2. That'll be 1/3, 2 cubed. Calculator says 8/3. And then find big F of A, which is big F of 1. And that'll be like this here, which is 1/3. And then what you do based on the equation is you go F of B minus F of A. So you take these numbers and you subtract them. So let's go back to that green question mark. And let's actually complete this problem in blue. So this would be like, let me grab a pencil here. This would be like a 8/3 minus 1/3, which is a final answer of 7/3. 100% finished. Let's try one more problem before we go. You'll probably see something like this tomorrow. So we begin by setting up our integral. And it goes from our a and b values, which are given. And then in the parentheses, you copy the original given equation. You punctuate it with the dx in the back. And then equals, well, we don't know yet. Let's just leave it ... for now. So what we do is we go down here and we find big F of x, where big F is the antiderivative of that, which is little f. So let's see. Let's go piece by piece by piece, antiderivatives. The first piece, carry the negative. Look only at x squared. Its anti would be 1/3 x cubed. Done. Next piece, carry the addition. And keep the 3. Now the x. What's the anti of x? Well, that'd be 1/2 x squared. And the 3 will multiply with the 1/2 in just a moment. Subtraction. What's the antiderivative of 4? 4x. If you want to clean this up a little bit, we could call this a negative 1/3 x cubed. In the middle, just go 3 times 1/2 to get 3/2. And now we're ready to find big F of B. So we go negative 1/3. 2 cubed plus 3/2. 2 squared minus 4 times 2. Okay. And calculator, reach for a calculator. Let it do the arithmetic. That's negative 14/3. Now let's repeat this again, but this time we'll find big F of negative 1. You do the same steps, right? You plug negative 1 and on a calculator, you're going to get 35/6. And then so to finish off this problem, what you do, let's go back up here to the orange and let's finish in purple. So now we need big F of B minus big F of A. And big F of B, we said was negative 14/3, take away. Big F of A was 35/6. And you type all that in, and you should get in return negative 21/2 squared units. So the answer is negative because maybe the picture is under the x-axis from there to there or something like that. But the point is, for all these problems, find the antiderivative of that and call it big F. And then go big F of B, big F of A, and subtract them in that order. And that will be your final answer.